to rearrange the equation. So as I said, you need, I know one formula, so I will use that. So how will I rearrange this? I'll multiply both sides by 1.8, basically cross multiply. So f minus 32 is equal to 1.8 multiplied by degree C.
Yes.
And so f equal to,
Oh, goodness.
so f equal to 1.8 C plus 32. So you use that in the calculator, use that values, and that will be the value of it.
1.8.
I got 209.
Possibly. What did everybody get?
No, I'm
I'm
still.
depending on you guys.
32.
0.212. 209.12.
All right. 200, you said 209.12.
209.48.
48. Okay, let me do it then.
Okay.
1.8 multiplied by 98.4
Oh, that's a 4. It looks like a 6. Ah, hold on. Let me.
equal to plus.
1.8
I'm
times.
getting 209.12.
Wait, hold on. I put 4 instead of that. I mean, I put 6 instead of 4. That looks like a 6.
Now, how much should I take? How many decimal points will I take?
4.
So 1.8 is exact. Okay.
Yes.
So
Okay.
1.8 is exact.
Okay. I put 98.
And this is one decimal place. I'm multiplying with the exact quantity. So my answer cannot be any more accurate than what I started with. So what is the precision of my thermometer? One decimal place. Now, if I make it two decimal place, then it's becoming too much accurate. I mean, that cannot be true.
Yeah.
So I have to keep to this, and this many degree Fahrenheit. So the correct answer is 209.1.
1. You round it.
I am saying 1 and writing 1 too. So 1, because my starting value was one decimal place of accuracy. I cannot be any more accurate than that. Just because my calculator is giving it doesn't mean I'm right. So
Yeah.
that is the decision that you need to take.
That's why I don't like to use a calculator.
We have Kelvin.
Yeah.
Now, can you jump from Kelvin to Fahrenheit? You cannot. But we have two pieces of formulas. I can go from Kelvin to centigrade and centigrade to Fahrenheit. 2 steps.
Okay.
So let's do it step by step, okay? First go to centigrade, but
So-
don't round it at that step, but keep the whole big thing that you have and then put it into the Fahrenheit. Okay.
Oh,
Well, Celsius plus 273 over.
so we don't round the Celsius once we get it?
Yeah. The final is the Celsius as an answer you do round it.
Okay.
But when you use it to calculate the Fahrenheit, use
That's
the raw data.
Oh, okay.
Because that's a separate question, right?
Got it.
Okay.
So everybody okay with what you are doing?
Yes.
So we are in this, we are using the first one, the second equation, okay? So K equal to C plus 273.
Over.
And so C equal to K minus 273. So our K is 435
Yeah, that's what I got.
minus 273.
Yes.
And whatever you are getting there,
Or nope. I didn't do that part. I must have step 435.
So 100
Professor, it doesn't matter if we omit or we leave the 0.15.
Yeah,
well, yeah, the actual accurate number is 0.15, but for this class,
It's okay.
if you don't remember the 0.15, I'm okay with that.
Okay.
But 0.15, the 273.15 is the more precise data.
Oh,
So if you want to use it, you are okay. I'm fine. Just
Oh.
go ahead and do that. So that's more precise, more.
Yeah, that's. And I got the same answer, but I had to round.
See, let's say if you do that,
calculator.
or if I do it your way. So how much I'm getting?
It's 161.85. So it's gonna
8.85.
round.
Now again, so basically, you cannot keep a decimal place, right? Zero decimal
Yeah.
place. So it basically comes down to 162.
Okay.
But you know, sometimes you might want to use the 1.5 because if your delta, like say delta T is very small, then 0.15 may be something very
Different. Okay.
but not in this case. So once you get that, you can take this and you want to get to the Fahrenheit.
Yes.
So again, we'll do the same thing for number 2 or B, let's say. This is A. So now C equal to F minus 32 divided by 1.8. Now, those who, you know, if you haven't followed what I did last time, I cross multiplied. So when I cross multiply, you have to remember there's a 1.
Yes.
That's 1.
Okay. So so what I'm getting is
F equals 1.8 C.
1.8 C, same thing. So if I remember one formula, all I have to do is to rearrange it. So don't just remember many formulas of the same thing. And so if I add, you know, plus 32 on both sides, is basically same as taking the 32 on the other side. Okay. So what you get is F equal to 1.8 C
plus 30.
plus 32.
Because you isolated the Fahrenheit.
Right. I isolated the F.
Yes. Because it's not.
And our C is 162. Okay. And when you use the calculator, there's another level of errors that you get, or I would say mistakes that happen in the calculator. So be careful when you're using the calculator.
Yeah. All right.
So how much are you getting?
Oh.
323.6.
No, that's no decimal.
So we need to write it as
324.
what's the next number?
4.
Yeah. So I would truncate at 3 and then I look at the next number. It's 5 and above. When it's 5 and above, you truncate and add plus 1. So when you round, this is going to be 324. So that's the correct answer.
Yes.
Okay, so from this chapter then, so this is one kind of questions you'll get, mathematical. Okay, conversion between this unit cell of temperature. Then another is, as I said, we have the example converting from joules to calories. So you can look at that. And now this kind of problem for the heat energy that we have in the slide. Okay, so here we are going to basically use Q equal to MC delta T. Now I will make some questions for you. Okay. And you can get a lot of questions from the Libert textbook. There's so many books there. So end of the chapter problems. So try them at home. And if any point, you think that some problems need my help, please bring it to the class. Okay. So let's say that the question. So you have a block of iron. It is heated by adding 55.0 joules of heat. Specific heat capacity is given. If the initial temperature was, okay, the mass of the iron. That's the mass of the iron. So identify what is given and what you are asked.
Oh, 535. Is that a 0.0?
Yeah, 0.0.
Oh, okay, that's the given.
So what is that? That is Q, right?
Uh-huh.
So write down what you have. So I'll have the small table here, 535.0 joules.
Mm-hmm.
And what else do I have? I have C.
0.449 joules of
And when
Clement.
you write the units too. Okay, what else do I have? I have mass. And I have Pi. And I need to find out the Ti. So this table basically summarizes, the whole question. But you should always go back and check that you have noted down the numbers correctly.
Mm-hmm.
And then now, in order to find TF, I need the delta T. So that's the easiest way of doing it, right? So I can isolate delta T, figure out delta T, and once I get delta T, I figure out TF. Go step by step. So that is what I'm going to do. I'm going to use Q equal to
585.
Mass times specific heat capacity.
okay. So delta T
Temperature.
is equal to Q divided by M.
Mm-hmm.
So basically,
Oh, this one.
if I isolate delta T, then MC, if I divide both sides by MC, I'll be left with this, right?
Mm-hmm.
So I isolated, delta T here. So now all I need to do is to substitute the values. So what are the values I have? So 535. Now when you write it with the units. My M is 52.0 grams. And
Times.
I have a delta T.
Mm-hmm.
Where is my mass?
All right.
I did something wrong. This is not delta T.
That's
See.
specific heat capacity.
Yeah, but when I was watching this, so how did I catch it? I could see my units are not canceling out.
Yeah.
Okay, so something is wrong. So writing units is always helpful.
So it's gonna be
All right, so 0.449
mm-hmm.
joules per gram degree centigrade. Okay, now I can cancel the joules. Oops. So cancel joules.
Cancel. Mm-hmm.
Okay, and what else can I cancel? I can cancel the grams with the grams.
Grams.
So I am left with
We're trying to find the T.
yep. So my delta T is equal to, now I need to write down the numbers, okay, before I put into the calculator, because I don't want to do anything wrong. And my unit, see the delta C here? That's my unit. Okay, so if it is divided, it goes up. Okay, that means if I multiply both sides by delta C, you can think of it this way, that if I multiply, so think of it this way, that you are multiplying both sides by delta C and delta C. So delta C and delta C cancels out. You're left with delta C. I mean degree C, sorry, degree C. So my unit is actually degree C.
Mm.
Oh.
22.9. So we are getting 22.91. That means we can round it to 22.9. Okay, Rocio got 23.
Oh,
And
yeah.
so why do you think, Rocio, you are getting 23?
Well, I got 22.9, but then I rounded. I'm not
Oh,
sure.
I see. Okay. Yeah, no, we need this in 3 decimal place. Three significant figure, because we are see 535 is 535.0 is 4 sig fig, and 52.0 is 3 sig fig. So the least number of sig fig is 3. So you have to keep to 3 significant figure. That is 22.9.
Oh, okay, 22.9.
So 22.9 is the correct answer. Now that is delta T. So that's not our. So that's not our
Delta T?
delta T. Now our delta T. Remember, delta T. What is delta T?
Ti plus
TF. TF minus TI.
minus.
Okay, so always delta means difference, and so I need my TF. So TF is equal to delta T plus TI. So my delta T is 22.9, and my TI is 25.0, and all this in degree centigrade. And so the correct answer is
47.9.
yep.
I got lost.
Now all of these problems are similar, so it doesn't matter, if practice similar kind. Look at some examples from the book. So this is all this calculus about MC delta T, and that's the formula that we need. And the other thing is then, so this is where your substance is in one phase and the temperature is rising. But when you're melting ice, when there's phase tension, the temperature remains constant at 0 degrees centigrade. So you can have ice at 0 degrees centigrade and you have water at 0 degrees centigrade. So as you are melting, there's no change in temperature, but yet the substance would absorb heat. So in that case, we use the formula M into delta H. Okay. So if you look at this, the situation here, here you are, ice is melting, and if you put a thermometer here, as long as ice, the temperature will hold at 0 degrees centigrade. Okay, but it is still absorbing heat, and this is called the heat of fusion. Fusion means melting. Okay, uh, and this heat is used to overcome the intermolecular forces. Okay, but the temperature is still the same at 0 degrees centigrade. And so if you do a heating curve, like if I take ice at minus 20 degrees centigrade, okay, and if I heat it, so on the x-axis you have heat added and the temperature on the y-axis, you can see that gradually the temperature of ice is going to rise from minus 20 and will reach 0. So as soon as it reaches 0, it will start to melt. And even though it is absorbing heat, there is no change in temperature. It's remaining horizontal. And then when all the ice has melted, the temperature, so everything is water now at this point. And so it will rise from there, and will start rising and go all the way. It can go all the way up to 100 degrees centigrade when it will start to boil. Now, when it starts to boil, again, the temperature will become constant. But if you look at this part, the melting curve of ice, so this horizontal part is where the ice is melting. Okay. Uh, so this is how all heating curves will look like when there's a phase tension. Okay. And if you do that for water and up to the boiling, and then at boiling, the temperature will again go constant. And this is general nature. Now, at this point where it is melting, the temperature is not changing, but it is still absorbing. And so we define another kind of heat, which is the heat of fusion, which is basically defined as the amount of heat required to melt 1 mole. Now we haven't done mole, okay, but you can also define it as 1 gram. So 1 gram. For ice, that's like 80 calories per gram. So in order to melt ice at 0 degrees centigrade to water at 0 degrees centigrade, that is the amount of heat you have to give. In joules, we say 6.02 kilojoules per mole. Now again, we'll learn about mole in later chapters. Okay. But we can also have this in grams. Okay. So when it is melting, it is absorbing heat. And the reverse, that when you are freezing, it will give the same amount of heat. It's basically equal and opposite sign. And it's called the delta H fusion or heat of fusion. Okay. And if you are doing it in grams, like 6.02 joules per gram, then if I get 10 grams of ice and I want to melt it, okay, so it will be 60.2 kilojoules. Okay. And there's no delta T term because there is no change of temperature. So the delta H is negative because is exothermic. So exothermic means heat is given out from the ice. So it's losing, okay, it's a loss of heat. And that's why it is negative. That's why it is negative. So the sign convention also need to be considered here. Okay, now here's a simple question that calculate the amount of ice in grams that upon melting absorbs 237 kilojoules of heat. Now the heat of fusion is in kilojoules per mole. Now take it for granted for now that 1 mole of water is 18.02 grams. And I'll tell you later how we come to that values. But when I give you questions for this, I will give you in grams. Okay, so not moles. So basically, you are multiplying and canceling the units, and you are getting 709 grams. Now, if I give you in grams, like the same questions, calculate the amount of ice in grams that upon melting will absorb 237 kilojoules of heat. But instead of saying 1 mole, I would say for this one 80. So 18 to 4.18, that's 332, I think. 334.7. So 334, let's say 334 joules per gram. Okay, so if I give you this, then how do you calculate? So 237 kilojoules, right? 237 kilojoules. Now, kilo is 10 to the power 3. So you have to have everything in joules. Okay, so we'll write 10 to the power 3 joules. And my heat capacity is 334 joules. Okay, hold on. How do we use this? So in order to convert, I will first place my units. Okay. So I need to cancel out the joules. I need the ants in grams. So if you look here, 334 joules per gram, that means 334 comes here. So if you go to this PDF, there's some extra things here, okay? Heat, sorry, energy and nutrition. That section is not there in the slide, okay? So I included them in the PDF. So this PDF is basically a summary. Uh, the classification of matter, I'm not going over this. Uh, and then you have the states of matter, solid, liquid, gas, physical properties, chemical changes, temperature scales. Okay. So in the temperature scale, you know, you do not have to look at the blue one because it's like how you got to that formula that you are using for conversion. But if you want to look at it, you are welcome. Okay, that's why I have it in different color, but it says how we got to the formula. It's basically a solution of a straight line. That's all. Equation of a straight line. Very simple. But if you want to know, I can quickly tell that. Uh, so when you're thinking of ice, so that's one point in the graph, right? So ice, I can have 0 degree centigrade, or I can say 32 degree Fahrenheit. So these are my points here. So these are my points. If you think, so if you think that this is a straight line, this is my point on ice, 0 degree and 32 degree. Okay, so X and Y. And if I think boiling water, this is another point, which is 100 degree and 212 degree. So you have 2 points, and you know, if you remember how to do that from your algebra class, actually, the Math 2. So we say 2-point equation. From 2 points, can you generate equation of a straight line? So the and that is the formula I use. Okay, x minus x1 divided by y minus y1 divided by x minus x1 equal to slope of the line. But again, you don't need to. So this is not part of the course. But if you want to know how we got this formula, only then as extra studies. Uh, and this is what I want to point out: energy, okay, kinetic potential, the conservation of energy, units of energy, and the conversions, okay, and then heat and calorimetry. Calorimetry is what we actually saw in the video, okay, that when you are taking water, adding hot metal into it, you are doing calorimetry. So calorimetry is basically a measurement of heat, technique of measurement of heat. Uh, all right. So again, okay, this is what I wanted to calorimetry, and then energy and nutrition. We haven't talked about that, but there's something that uh, people going into medicals also interested in all these nutritions and things would need. Now, very simple. So when you burn in a carbohydrate, so for every gram of carbohydrate is 4 kilocalories. So we say 449. 449 carbohydrate and protein is 4, fat is 9 kilo. That's the amount of energy you get. Okay. And in joules, kilojoules is there. So just remember the calories. Okay. Um, so now if you have like a food where we know how much carbohydrate, fat, and proteins are there, you can easily calculate the total calories. And this is part of this course. Okay, calculation of calories. So here are some examples. It's simple. Simply you multiply. Okay, like hamburger contains 17 grams of carbohydrate, 19 grams of fat, and 23 grams of protein. What is the energy from each food type? Yeah, so basically simply multiply them, and then you get the energy, add them up, 400 kilocalories. Now again, nutrition, remember there's a big cal, which is 1000 kilocalories, means 1000 calorie. Means 1 kilocalorie is big C. Okay, calorie C. So this is additional thing that is not there in the slide. Remember, it's not there in the slide. It's here. Okay.
Okay.
And so you can try any of these books that are showed in the liver text. Practice their examples. There are a lot of examples there. So if you are confused, look at the examples in those books. Okay, how they're doing it. And then there are the videos that I give you.